Welcome to this explainer, where we're going to dive into the surprisingly fascinating world of automotive headlight replacement. You know, if you've ever been driving on a pitch-black road at night and noticed your visibility suddenly just drop off, you know exactly how crucial a properly functioning headlight really is. But today, we're going way beyond just, twisting a bulb in and out. We're going to empower you with the actual knowledge to understand exactly what is happening inside your car's lighting system.
So, here's our agenda for today's masterclass. First, the basics of bulb tech. 2, why headlights actually fail. 3, the golden rules of replacement. 4, a step-by-step installation guide. And finally, number 5, final checks and alignment.
All right, let's jump into section 1, the basics of bulb tech.
To really understand what's lighting up the road ahead of you, it helps to see how we got here. Looking at this timeline of lighting innovations, it's pretty incredible to see the leap from those very first electrical automotive lighting systems way back in 1913, right up to the launch of the first halogen lamps in 1964. And halogen, well, it completely changed the game by passing an electric current through a tungsten wire inside a halogen gas mix. But the real modern breakthrough? That happened in 1991, with the release of the first xenon HID headlamp system. Okay, so let's unpack this definition of high-intensity discharge, or HID. It sounds super technical, right? But basically, instead of a glowing wire, HID uses an electric arc. When a current is applied, highly pressurized xenon gas ionizes between two electrodes. This arc generates extremely high temperatures, which causes metallic elements inside the gas to vaporize and release just massive amounts of visible radiant energy. And the result of all that chemistry? That incredibly vivid, bright, daylight white beam that easily cuts through the darkest nights.
Now, when we compare these two directly, it's pretty wild how much HID outperforms traditional halogen on almost every single metric. Just look at the energy consumption. HID only needs 35 watts to operate, whereas a standard halogen needs 55 watts or more. And the service life is literally night and day. A halogen bulb generally averages around 400 to 500 hours. But that HID lamp, it'll easily last 2,000 hours or more. That is at least 4 times longer, all while producing a crisp daylight white color rather than halogen's yellowish tint. And honestly, this side-by-side comparison perfectly illustrates the practical difference when you're actually out on the road. You can clearly see the superior distance and spread of the HID xenon beam pattern on the left. It just reaches so much further down the lane, and with way higher intensity. Then compare that to the standard halogen pattern on the right, which drops off much faster. HID is simply a massive upgrade for eliminating the road ahead.
Moving right along to section 2. Why headlights actually fail. So, if these bulbs are so carefully engineered, why do they suddenly just die on us? Well, it usually comes down to a few main culprits. First is just plain old age. As we noted, halogens only average around 500 to 1,000 hours. The tungsten material actually evaporates and redeposits in a cycle that just eventually wears the filament out completely. Then you've got extreme hot or cold temperatures causing that tiny filament to expand and contract over and over, which causes internal stress. Toss in the constant vibration from your engine, and yeah, that fragile filament is eventually going to snap. And finally, even a tiny crack in your headlight housing can let water and grime seep in, instantly shorting out the bulb entirely. But hold up, before you rip out a bulb and spend your hard-earned cash, you've got to ask yourself, is it actually a bad bulb, or could a blown fuse be faking a dead headlight? This is a super common, highly overlooked issue. If both of your headlights suddenly stop working at the exact same time, that is a huge red flag pointing to an electrical issue or a blown fuse, rather than simultaneous bulb burnout. Checking the fuse box first can be a quick, super cheap fix.
Which brings us to section 3, golden rules of replacement.
All right, so you've checked the fuse and you've confirmed it's definitely a dead bulb. Before you start wrenching under the hood, there are a couple of golden rules you have to follow. This one right here is a non-negotiable safety mandate. Always replace them in pairs. Why? Well, because when one headlight burns out, the other is usually living on borrowed time. Plus, an older bulb is going to be significantly dimmer than a brand new one. If you only replace one, you're going to end up with a weird, mismatched beam pattern on the road. And that isn't just visually annoying for you, it's genuinely distracting to other drivers and reduces your overall nighttime visibility. So always swap them both out.
Now, onto the most famous rule of DIY car repair. If you've ever watched a tutorial, you have definitely heard this warning. But really, why must you avoid touching the glass of a halogen bulb at all costs?
It all comes down to chemistry and thermodynamics. When bare skin touches that glass, it leaves behind microscopic alkaline compounds and natural oil residues from your fingers. Because these bulbs run incredibly hot, those oils create localized hot spots on the glass.
This uneven heating severely weakens the glass structure, completely ruining its lifespan. It can cause the glass to crack, and in rare, extreme cases, the bulb might actually explode while you're driving. So always, always wear clean gloves. Seriously, don't skip that step.
All right, Section 4, Step-by-Step Installation Guide. Let's get our hands dirty. Well, actually, scratch that. Keep the clean gloves on. You've got your gloves, you've got your matching pair of bulbs, so let's execute the sequence and safely swap these out. Here is your universal replacement guide. Step 1 is gaining access, which we'll talk about in a second. Step 2, carefully pull the wiring connector straight off the back of the bulb. If it's being stubborn, a flathead screwdriver can help ease it off. But whatever you do, never pull by the wires themselves. Step 3, remove the old bulb by unclipping the metal retainer or rotating the bulb counterclockwise, usually about 75 degrees. Step 4, insert the new bulb, wearing those clean gloves, placing it in at the exact same angle you removed the old one, and twist clockwise to lock it in. Finally, Step 5, push the wiring plug back on until you feel a solid, satisfying click.
Now, I gotta be totally honest with you. Step 1 can sometimes be hilariously frustrating. Depending on how your vehicle was designed, you might open the hood and have wide open, glorious access right behind the headlight. Or you might find yourself doing minor surgery. Like on a Subaru Impreza, you might literally have to pop out the air intake duct on the passenger side and shove the washer fluid tube out of the way on the driver's side. On some early 2000s Honda Accords, you have to completely remove the car's battery just to reach the housing. So always consult your owner's manual first so you know exactly what you're getting into.
And finally, Section 5, Final Checks and Alignment.
All right, you've successfully navigated the engine bay, you've got the new bulb securely in place, and your hands never touch the glass. Awesome. But a super common question pops up right about now. Do you need a full beam alignment after a simple bulb swap? Like, if the new bulbs are way brighter, are you going to accidentally blind oncoming traffic? Thankfully, the answer is usually no. Replacing a bulb doesn't actually alter the headlight aim at all. The housing itself dictates where that beam of light goes. So, unless you had to physically unbolt and completely remove the entire headlight housing from the frame of the car to squeeze the bulb in, you really shouldn't need to do any realigning. Just turn them on, make sure they both light up evenly, and you're good to hit the road. You know, looking closely at how this standard halogen bulb works, knowing exactly how this fragile little tungsten filament functions, how it evaporates, and why it ultimately fails, it really empowers you to handle routine maintenance with absolute confidence. You're saving yourself a trip to the mechanic, you're keeping cash in your pocket, and most importantly, you're keeping yourself safe on the road. But it does leave us with one final, kind of crazy thought. We've mastered the halogen and HID swap today, for sure. However, modern automotive engineering is shifting incredibly fast toward non-serviceable integrated LED units that are literally designed to last upwards of 30,000 hours. If an LED fails in one of these newer cars, you often have to replace the entire headlight assembly. So it really makes you wonder, is popping the hood and twisting in a fresh set of bulbs about to become a totally lost art? Well, until then, keep those gloves clean and your headlights shining bright. Thanks so much for joining me on this explainer.